going to look at a required practical, which is to identify alcohols, aldehydes, alkenes, and carboxylic acids using test tube reactions. So our method comes in 4 different parts. So the first part is testing for alcohols, and we're going to add a small piece of metallic sodium to about 1 centimeters cubed of ethanol in a dry test tube and record the observations. Now, before we looked at identifying alcohols by adding acidified potassium dichromate, but this time we're going to add some metallic sodium. And then the second part is to test for aldehydes. So in a clean test tube, mix together equal volumes of failing solution A and failing solution B, and the resultant failing solution should be a clear dark blue solution. So whenever we make failing solution, we actually already have 2 already made solutions, and we just have to add them together to form our failing solution, which we can use to test for aldehydes. And so for step 2, we add 5 drops of this failing solution to about 1 centimeters cubed of sodium carbonate solution in a test tube containing a few anti-bumping granules, and then add about 1 centimeters cubed of ethanol to this same test tube. We then warm the test tube gently for approximately 2 minutes in a beaker half filled with hot water or a water bath, and then gradually bring the beaker of water to boiling and maintain this temperature for a few minutes. And using a test tube holder, we carefully lift the test tube out of the boiling water and allow its contents to stand for several minutes before recording our observations. And then for part 3, testing for alkenes, to about 2 drops of cyclohexene in a test tube, add about 1 centimeters cubed of bromine water and shake the contents of the tube vigorously from side to side and record the observations. And then the last part will be testing for carboxylic acids. So we place a small spatula measure of solid sodium hydrogen carbonate in a test tube and add to it about 2 centimeters cubed of dilute ethanoic acid and record the observations. So for the test for alcohols, when we add a small piece of metallic sodium to ethanol, what happens is that we'll have some effervescence. So we'll have some fizzing of the sodium. And this is because hydrogen gas is given off. If we look at the equation, what we have is that 2 moles of this ethanol reacts with 2 moles of sodium, and this forms what we call an alkoxide, but you don't really need to know that. So it's CH3CH2ONA and hydrogen gas. So hydrogen gas is the fizzing that you can see. And there'll also be a rise in temperature of the test tube because this is an exothermic reaction. And then testing for aldehydes, by using failings, if there are aldehydes present, what happens is that the failings goes from a blue solution to a brick red precipitate. And then for alkenes, the bromine water should go from orange brown to colourless if there are alkenes. And then for carboxylic acids, what's produced is carbon dioxide when we react carboxylic acids with sodium hydrogen carbonate. And so effervescence or bubbles should be given off. And if you want to test it further, if you want to test the carbon dioxide, we could use some lime water. And the lime water should go from colourless to cloudy if it is actually carbon dioxide.